This video is going to look at acid-base indicators. So acid-base indicator is basically a weak acid or a weak base. What's going to happen when we put an acid into an indicator or indicator into an acid is it will change colors over a certain range. So if you could open your reference table to table M, I just want you to look at how table M works in terms of pH. So methyl orange, the range is 3.2 to 4.4. The number on the left and below corresponds to the color on the left. So for example, if I have a solution, I add methyl orange to it. If the pH of the solution is 3.2 or lower, meaning the number of the left or the range or lower, it will be the color on the left, red. If it's 4.4 or higher, it will be the color on the right, yellow. So if I have a solution that has a pH of 7, well, that's 4.4 or higher, so it'll be yellow. If the pH of the solution was 2, well, that's 3.2 or lower, so it would be red. Bromethymol blue, if we add that to a solution, if your pH is 6 or lower, you'll be yellow. 7.6 or higher, you'll be blue. If you're in the middle, you're going to be something like green. We don't typically use the pH indicator when you're in the middle because we'd like to be able to say for sure what you are. And in the middle, green, we can't tell exactly what your pH is. Phenolphthalein, if you are 8.2 or lower, you're colorless. If you're 10 or higher, you're pink. So if I test a solution with phenolphthalein and it turns pink, I know for sure it's a strong base because its pH is high. Litmus, if you're 5.5 or lower, you'll be red. If you're 8.2 or higher, you'll be blue. Bromcresol green, 3.8 or lower, yellow, 5.4 or higher, blue. So the idea is that if you're looking at the number on the left or lower, you're the color on the left. If you're the number on the right or higher, you're the color on the right. Next, we need to know this formula for a neutralization reaction. Neutralization means you add an acid and a base, and you get a salt and water. And we mentioned before that salt is just an ionic compound, and water in this case may be written as HOH. So let's just go through a few examples of how you write a neutralization reaction. So HNO3 plus KOH, what's going to happen is it's just a basic double replacement reaction. So the H, so here the H of the acid and the OH of the base are going to form water, which we sometimes will see as HOH. Oh my goodness, what is up with this calibration? So you'll get the H and OH will come together. You get HOH, which is water, and you get KNO3. But remember, when now you write a new compound, just make sure that your formula makes sense. K is +1, NO3 is -1, so it's all balanced out. Here, H and OH will combine to form water, and Mg and Cl will go together, but Mg is +2, Cl is -1, so it will become MgCl2 and water, which you could write as HOH or H2O. The Regents accepts both, whatever you like. I like H2O. Here, NaOH and H2SO4, the H and OH will come together to form water. And you'll get Na and SO4. Remember that Na is +1, SO4 is -2, so you have Na2SO4. So anytime you add an acid and a base, the H of the acid and the OH of the base are going to form water. And then you're left with a positive ion and a negative ion, so they'll form your salt.